How do you train someone to fight an enemy they can't even see? That is the absolute core challenge of cybersecurity. We've got to build defenders who can outsmart attackers in a digital world that's changing, well, every single second. But what if you could use AI not just to attack or to defend, but to build the perfect classroom? I'm talking about an unhackable training ground that learns, adapts, and creates challenges way faster than any human ever could. So let's pull back the curtain and see exactly how this works. So here's the game plan. We're going to start with a tough training gauntlet that cyber defenders have to go through. Then we'll get into the agentic AI that's really changing the game. We'll see how it all works with a pretty cool self-correcting system. Then zoom way out to the massive copyright debate this whole technology has kicked off. And finally, we'll look at what this all means for the future of cyber education. All right, first up, the gauntlet. To train a cyber defender, you need a training ground, right? Think of it like a digital flight simulator, but for cyber attacks. The problem? Building one that's actually realistic, well, it's incredibly difficult. It sounds like such a simple question, doesn't it? But the answer is super complex. You can't just hand someone a textbook and say, good luck. They need hands-on experience in a safe, controlled environment that feels real. We're talking complex networks, specific vulnerabilities, and realistic data traffic. And that right there is the bottleneck. You end up with a situation like this, just a huge headache. Traditional methods take a ton of manual work from very expensive experts, they're technically a nightmare to build, and they don't scale well if you have a lot of students. But the worst part? They're static. By the time you build the perfect simulation of today's threat, tomorrow's is already out there. So how do you break through this bottleneck? Well, researchers are turning to a new kind of AI. But to really get the solution, we first need to understand the engine that's powering it all, the large language model, or LLM. An LLM isn't really thinking the way you and I do. It's more like a master of statistics. It's been trained on a colossal, just unbelievable amount of text and code. And from all that, it's learned the patterns, the relationships, the very structure of language and logic. It's all about probability. And at its core, the idea is surprisingly simple. An LLM's main job is just to guess the next token, which is basically a word or even just part of a word. So if you give it that famous line, it was the best of times, it was the worst of, it doesn't know the book. It just knows that, statistically, the token that most often follows the worst of in this context is times. That's it. It's a really powerful but simple prediction machine. And here's a little peek under the hood. The words we see get converted into these numerical tokens. The model isn't processing the word wisdom, it's processing the number 32646. This is what lets it do all these mathematical calculations to figure out which number is most likely to come next. And from there, it just translates that number back into a word for us. Pretty neat, right? Okay, so we have this powerful prediction engine. How does that help us solve our original problem? Let's take a look at how it's being put to work to build a better cyber classroom. But here's the catch. If you just ask an LLM straight up to generate a complex cybersecurity training scenario, it usually fails. In early tests, less than 40% of the scenarios it came up with actually worked. I mean, they looked right on the surface, but they were full of logical errors, broken network configs, all sorts of problems that made them totally useless. The AI is creative for sure, but it's not reliable. This is where a system called agent sites comes in. Think of it like a supervisor. The AI on the left proposes a scenario, but it doesn't get a pass just yet. Oh no. It has to go through a whole series of automated checks and validators on the right that act as quality control. It's this partnership, this feedback loop between the AI's creative spark and a really rigid rule-based system that forces the final product to be correct. Now this is the secret sauce, the agentic feedback loop. It's way more than just trial and error. So the AI proposes a scenario. The system validates it, finds a mistake. But instead of just trying one random fix, the AI first hypothesizes why it failed. Was it a missing firewall rule, an incorrect IP address? Then it generates several different potential fixes, tests them all, picks the best one, and this is the most important part. It learns from the results so it doesn't make that same mistake again. And you know what? The results are really impressive. This shows the number of rounds or attempts the AI needs to fix a problem. Just look at this. For small changes, it's often less than one attempt on average. Even for generating a whole new scenario from scratch, it only takes a couple of rounds. This just proves the feedback loop is incredibly efficient at self-correction.
And it's not just about being fast, it's about being effective. With every single round, the system is hammering out multiple errors at once. So we're going from that initial, 38% success rate to nearly 100%, creating these complex, functional, and realistic training environments completely automatically. This is a huge shift from AI as just a tool to AI as a self-correcting partner in creation.
So we've got a system that can learn and create these incredibly complex things. But what did it learn from? That single question about the data used to train these models is at the very heart of one of the biggest legal and ethical debates of our time. This quote from the US Copyright Office just perfectly captures the two sides of this fight. On one side, you have AI companies saying, hey, we need access to all this public data to innovate. But on the other, you have creators and artists who fear their work is being used without their consent to build systems that will ultimately compete with them. This all boils down to a legal concept called fair use. AI developers argue their use is transformative. They say they aren't making copies, they're just creating a statistical model to learn patterns from. But creators argue that because the AI can spit out works that compete directly with the originals, it's not transformative, and it's basically appropriating the value of their work without permission. And at the technical heart of this whole debate is a really crucial question. Is the AI truly learning abstract concepts from the data, kind of like a human student would? Or is it, in some cases, just memorizing and repeating what it's seen? Well, the reality is, memorization does happen. While developers are absolutely aiming for generalization, models can and sometimes do reproduce their training data word for word. It's often described as a bug, not a feature. And it's more likely to happen when the same piece of data shows up over and over again in the training set, or when the data is really unique. This, as you can imagine, is a huge point of contention in those copyright lawsuits. Okay, so let's bring this all back together. We've got this incredible new tool for building cyber defenders, but it's built on a foundation of data that is shaking up the creative and legal world. So what does this all mean for the future? Here's the bottom line. AI-powered tools like Agent Sight are revolutionizing how we can build comprehensive training programs. It's no longer science fiction. They make it possible to build realistic, adaptive, and scalable cyber classrooms. But this innovation doesn't exist in a bubble. It forces all of us to confront these incredibly complex new questions about data rights, copyright, and what it even means to create something in the age of AI. And that leads us to one final kind of provocative question to leave you with. This technology is an unbelievably powerful tool for education and defense. But like any tool, it's neutral. So if this AI can build the perfect unhackable classroom for our defenders, what's to stop it from being used to build the perfect training ground for the attackers of tomorrow?